Alright, hello and welcome to the programming lecture for the week. Not a long lecture today, but important topics. Clones, messages, and Pong. Oh my. So let's go ahead and get started with clones. And they're a very, very useful concept. So each sprite in Scratch, we've just been having one of them. But you can actually have as many of each sprite as you would like, because all the sprites know how to clone themselves. Which is fun to think about. They can make as many clones of themselves as you ask them to. So that's fun. And I'd like to make a nice little star field for you with clones. So we're going to make space and a bunch of stars, and the stars will have different sizes. Okay, this will help practice all the cool stuff that we learned in addition to clones. So, yeah. Let me first show you clones in general, and then we'll make this star field. Alright. So, here is my Scratch Cat, and when the sprite, maybe when the green flag is clicked, we can have him make clones of himself. Okay, so that is what we want to have happen. Okay, dun dun dun. So go here down into Control, and it's called Create Clone of Myself. You can also create clones of other sprites, but there's no other ones in this program yet. So it'll say Create a clone of myself when the green flag gets clicked. Okay, I click the green flag, nothing happened. But secretly, there's that second clone underneath him at a different spot. So that was no fun. So click, 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 click. So it only ever makes 2 for this one. But we can, in a loop, make multiple clones. That's the idea. And they can all have different properties. So, yeah, that's cloning. Now we can have 2. There's just one sprite down here. And now we're ready for a star field with clones. So we're going to make a bunch of stars and clone them. So that's a pretty little background. Okay, so let's search for a backdrop. Space. Dun dun dun. I don't see stars. Oh, there we go. That looks nice. I'm happy with that. And bye-bye Scratch Cat, sorry. We are going to make use stars instead. Bam. So there's our star sprite. And no Scratch Cat, please. So we're happy now. So what I'd like to do is make, for the stars, 50 of them. Okay, so let's generate 50 stars in random spots with random sizes. And then we'll have them bounce around. I know that sounds like a lot, but it's going to be fun. It's not too bad. So to make 50 stars, we're going to need a loop, yeah? So we'll say, in a loop, do 50 times, hey, please create a clone of myself. Bam. Okay, so let's go here. When green flag clicks, let's make 50 clones of ourselves. So not 10 clones. No. 50. Okay, so this is what's going to happen when this green flag gets clicked. It will create a clone of 50 stars. So the star will create a clone of itself 50 times. Hopefully that makes sense. And when I click go, see how it's running, it's doing its thing. Unfortunately, they're all on top of each other right now. So there are 50 of them, but they're just all sitting on top of each other. That's no fun. What we would like to do is have all these stars go to random spots. Okay? So this program controls the original star, but we can have programs control the clones as well. And that is... Dun dun dun. Where is it? When I start as clone. It's down here by the cloning stuff. When I start as a clone means when the clone gets created, like it has life, bam, run this program please. And what we would like to do is make these stars go to random places. Okay? So that is the idea. So let us, when each clone gets life, it becomes sentient, let us tell it to go to a random position. Okay, so now each time we make a clone, the clone will begin, and it'll start, and it will run its own little program, which will always be this one. It'll go to a random spot. So, are you ready? That's fun already, isn't it? So that's making 50 clones of stars, and now we'd like them to be even more random. Okay, because this is fun. This is all well and good, but they could be of different sizes, they can have different directions. Let's make them look different, yeah? Let's try that. Let us do that. So, what I'd like to do, we can set this back to 90. That's fine. Random sizes. Okay, so not only when you start as a clone, go to a random position, but also change your size to be some other, some smaller amount, or some weird amount. So set size to be some percent, and let's make a random percentage. Okay, so you know how to make random numbers now. Pick a random, well, make some number between 1 and 100, yeah? Or maybe, let's make it like 50 and 100, so that they're not like the tiniest stars in the world. So now we can make a random number between 50 and 100 each time, and we can set the size to that, and so they'll have different sizes now when I run this program. Ready? Oh, that's nice. That's real nice. So now they're all cute, and some are small and some are large. Okay. Next, let's see, we can have them have random sizes and rotations. Yeah, why not? Bam, we'll need another random thing. How do we give them a different rotation? Dun dun dun. Where's the direction? Where can we set the direction to? Dun dun dun. Point in direction. Yes, yes, yes. They can say, please point in direction. Well, I don't know. Between 0 and 360, yeah? Or 1 and 360, because 360 is 0. So I get a random value for direction now, a random angle value. Okay. So every time a star begins its life, we're going to go to a random spot, pick a random size, pick a random direction. Let's do this. That's extra nice. Okay, okay. All right. After this, now, let's make things even fancier. Let us make all of these stars bounce around. Okay? We know how to do that now. So we can go and say, forever, dun dun dun. We can make them move a certain number of steps in your current direction. And if you ever get on the edge, well, just bounce off, please. Bam. So forever, keep on trying to move forward, 10 steps forward. That's what that means. And then if you ever hit an edge, bounce off of it. So this will move those stars forever. Okay? Whee! Isn't that fun? I love that. The one problem is, though, the original star that wasn't a clone, I think you can see it, it's not moving, it's still stuck there. We'd like to get rid of it because this program is not affecting it. And there's no use for that anymore. So we can hide it. Okay, we'll just hide that one star. And so that everybody's moving then. Okay, so we'll just hide that one star. I assume it's in looks. Hide the star. Bam. Or we can start it out hidden. Why not? But now the issue is all the clones are hidden. Uh-oh, because they're clones of the original thing, which is itself hidden. Uh-oh. So what we can do is we can show it, okay? We can show all the clones now, but hide the real stars. Yeah? So now we have a bunch of stars. The original one's hidden, but it cloned itself 50 times, and they all went to random spots with random directions, random sizes, and they're bouncing around forever. Isn't that cool? Okay, so that is the first part of this. I think that's fun already. The next thing that I like to do is like have some kind of distance effect. So we'll make the smaller stars more transparent, and that'll be fun. So let's learn how to do that. So the answer for transparency has to do with, let's just say show please. It has to do with a thing called the ghost effect. That's what they mean by transparency in Scratch, because this is meant for small children who have not learned a giant word like that yet. So we're going to change the ghost effect is the idea. Let's see where that is. I assume it's in look somewhere. So let's find it. Change color effect. Okay, yeah, so we're going to change the ghost effect, and that's transparency. So if I do that, it's going to change it by 25. So let me show you this. We can actually set it to a certain amount as well. We'll figure it out. I think that might be easier to start out with. Let's set it. Let's set the ghost effect. Bam. Not to 0. Let me show you 50%. So set it to 50. See how it's a little transparent? And 100 should be full. Now 100 is completely gone, I get it. Okay, 0 that means is completely showing. So we want to set our ghost effect between like, I don't know, maybe definitely 0 and then some large number that's not yet. Like maybe 90 is a good spot. I can barely see that. I don't know, like 80? That's still kind of visible. 70. We'll just pick a good one. So let's pick numbers between 0 and 70. Yeah? Let's set it between 0 and 70. Whee. Okay, so let's write that to remind ourselves. And yeah, this is exciting. What I would like to do is not have random ghost effect sizes, but set ghost effect sizes, if that makes sense. Maybe. You know, I don't think 0 to 70 is going to be the best idea because of the way we're about to do this. So let me get rid of that. But let me show you what I have in mind. We want the stars in the background. Like if they're small, they're in the background, right? Because they're farther away. We would like these to be a lot less brighter, so greater ghost effect. So let's say like this size is, I don't know, maybe this size is 50, and this size is 90. We would like the ghost effect for this one to be a lot larger than the ghost effect for this one, okay? So we need to come up with a mathematical expression to set the ghost effect to reflect this. So for a size 90, we should say, okay, its ghost should be ghost effect. Let's set that to, I don't know, some number that's very close to 0, okay? So maybe we could say, I don't know, 100 minus size. I think that would work, because if it was exactly 100, then its ghost effect would be 0, and that would be right in front of us and not at all transparent. Whereas this one would become ghost effect 10. This one would be ghost effect 50. Yeah? I think that'll work for us, for our purposes. So that means smaller things have a larger ghost effect. So they will have larger transparency and appear like they're in the background. Okay, so that's I think that's a good idea and a good way forward. So let us use that as our starting point. Okay, so we're going to set our ghost effect to be not 70, which would be a nice one. Let's set it to be 100 minus our size. That's a nice number, I think. And we can play around with that. You could be like 100 minus size times 2 or something, if you really wanted to. Let's see. Where do we get our size? Where's that variable? There it is. So our size is currently set to 100, of course, for that one. 100 minus size, please. So we can do that after we set the size and all the positions. Actually, maybe we can show it after all this stuff has been settled. It's going to happen so fast that the size and all the directions will have been picked by the time we see it, but this is probably the technically correct way to do things. So only show yourself once you've picked all these sizes and things. And so now we're going to set the ghost effect to be whatever 100 minus the size that we have decided to be is. Okay, so this is a bit complicated, but don't let it scare you, because it's all going to happen in order. So just try to remember that and try to walk through it. And so can you see now that the smaller stars, unfortunately when I stop it, they stop being clones. The smaller stars are more transparent, and that is quite nice. And every time we start this again, they'll all be different. Yeah. And maybe they're moving too fast for us. We can have them move like 5 steps at a time. That's a bit more manageable. Yeah? Maybe you can make them move faster if they're bigger. So I maybe give that a try. That would be fun to do. So that is, I think, everything that I wanted to show you. Just the fact that you can clone individual sprites is going to be very useful for the rest of this class, as long as we talk about Scratch, and super useful for your next programming assignment. So that is clones. Let me save this. Bam. And now let's make a new one. So the next thing that I want to talk about is messages, and message passing is the idea. It's the technical term for it. We're going to recreate that ghost program, but it's going to be a lot easier after we learn about this thing called messages. Okay, so technically it's called message passing. That's the concept that I'm about to teach you. Message passing. And so there's a concept of a sender, which is a sprite in Scratch, and then listeners who can receive messages. There can be multiple listeners as well. Okay, so the idea is, or the metaphor is, that the sender's got like a little blowhorn thing, like you're shouting into, and the sender also has a message to send. Bam. And so he can just shout out, hey, whoever's listening to me, I'm sending you this message. And then all the listeners who are like turning their ear towards the sender, they see that message and they're like, okay, I have received the message, I will act on it. And that in a nutshell is message passing. And we're going to make that ghost program a whole lot easier because of it. Okay, so let me show you this. Let's see here. So let's remember our program. We need a backdrop that's all spooky. So like a graveyard or night, Halloween, woods, yeah. Thank you. And we need ghosts, so I think I'm going to search for Halloween again. Bam, give me a bat, give me a ghost, give me a skeleton. Very nice, very nice. Let's get them all away from the scratch cat for now. And so again, we're going to be like, oh, do you believe in ghosts? When the program starts. Dun dun dun. Where's the ask? Oh, it's sensing, isn't it? Ask, do you believe in ghosts? And wait, and then the answer holds the answer that the user typed. And again, we'll be like, okay, if... Actually, we only need one if, don't we? If the answer was yes, then we're going to show the ghosts. Yeah? If the answer was yes, then show the ghosts. And I'm going to show those ghosts in a different way using dun 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 message passing. And I paused the video because it was taking me too long to find it. Sorry. It's up here in events. It is broadcasting things. So this is how you send a message with broadcast. You say broadcast whatever your message is. And we can change this message to be something different. So we can say new message, and we can call it show the ghosts. Yeah? And so we can say show ghosts, please. And that's essentially that. So that's our block. We're going to shout out as the sender. Shout out to the ghosts, hey, show yourselves. And they're going to listen. Okay, they're going to listen for this message called show ghosts. That's the whole point. All right, so it's fun. Let me show you this. They're going to become alive and active when they receive the certain message. So for the bat, let's say, when I receive the show ghosts message, well, please, well, that's telling me to show myself, so I should probably do that. Okay, so say show. That's what I want to do. And I want to start out hidden when the program starts as well, so we're going to have to do this as well. I have to say, when the green flag is clicked, we'll hide everybody. Yeah, we'll hide all the ghosts. So when the program starts, the ghosts will hide themselves, but when they are receiving this message called show ghosts, they will show themselves. Yeah, so let's give these programs to the other people. Ghost and skeleton, ghost and skeleton. So who knows where the other one went? No, they only got the one. All right. Did you get both of them? No, you only got the one as well. Well, that's okay. It's gonna keep on doing this until they both get them. There you go. There you go. And we'll zoom back in. So all that is happening for these ghosts is, oops, odd. Oh, I see what happened. They were on top of each other, darn. Delete, delete, and I accidentally got rid of this one, sorry. events when I receive the show ghosts message, show myself. So this is what's going to happen. When the green flag gets clicked, we're going to ask, do you believe in ghosts? And all the ghosts are going to hide themselves if they weren't already hidden. Okay? And then, if the answer just so happened to be yes, we believe in the ghosts, we're going to send a message to everybody who wants to listen. We're going to send the show ghosts message. We made up our own. We can call any message whatever we want. So we shout it out to all the ghosts, hey, show yourself. That's what the broadcast means. And then all the ghosts were listening. They have a separate program that runs when they receive the show ghosts message. And, well, all they have to do is show themselves in that case. All right, are you ready? So, do you believe in ghosts? So you see how they all hid themselves because their green flag programs ran. Do you believe in ghosts? No, we're not going to send this message, and so they're going to stay hidden. If we try again, do you believe in ghosts? Yes, we're going to send the message. And suddenly, they have all shown themselves because they respond to that message. When you receive show ghosts, please show yourself. Okay, I hope you see how this is a lot cleaner than the other way that we were doing it with a forever loop and variables, but this is essentially the same idea, but it's a bit easier to think about. All right, so technically you can make a variable and do everything like we were doing it last time, but message passing is a lot more powerful and easier to think about. Okay, so that's message passing. You'll need that for your next programming assignment as well. And then finally, I want to give you just a fun little example, which is Pong. Okay, it's going to just be a nice combination of everything, and it's going to be the most complicated program we've made so far, and it's just going to be very rewarding, I think. So let me show you how to make Pong now. So just in case you've never heard of Pong, though, let me introduce it to you. And the idea is you got two paddles on each side. It's like you're playing tennis or ping pong or something. And there's a ball. Right? And the ball is just moving. It's moving around. And the goal is to have it bounce off of your paddle and get it so that your opponent can't reach it. Okay, that's how you play Pong. That's how you win Pong, I guess. And the ball just bounces around all day long as it's hitting the paddles. But it's game over, or you lose a point at least, when it hits the wall. Yeah? So that's our game. This is what we're going to do. We're going to make a single player Pong, though, so there's not going to be a second player. It's just going to bounce off the wall over here, and we're going to play against ourselves. Okay, so it's going to be fun, though. Let's go ahead and get started. Make sure I'm recording. So here's what we want to do. Well, might as well save this. Bam. New. No more Scratch Cat. Sorry, Scratch Cat. We're going to need paddles. We're going to need a paddle. There's one of these. We're going to need a paddle. We're going to need a ball. There's a ball. We're going to need something to mark the no-go zone, the wall, the fact that, okay, you hit this thing, game over. So we're going to make the wall as well. So here's the wall. There's just a line here somewhere. Bam. And so it's not going to be this way. Let's make it sideways like usual. So let's make this like that. And we'll make the line also 0 degrees. There we go. Okay, so line's over here. Paddle's over here. Paddle's kind of tiny. Let's work on that. Like 150? That looks good. That's good enough for now, at least. So the idea is the paddle will move up and down, and the ball will just bounce around. Yeah. So some things that need to happen, though, and let's get these started first, is the paddle needs to only move up and down, not left and right. Okay, so we're going to have to make it so that it cannot move left and right. Like its x direction can't change, but its y can. What I'd like to do is make the paddle follow the mouse pointer. Okay, so if I move my mouse, the paddle goes up and down. Okay, so that's what I'd like to do. And I think that is not too bad to think about. So when the green flag gets clicked, when the program starts for the paddle, it's going to repeatedly just keep on putting its y value equal to whatever the mouse pointer's y value is. Okay, because like if my mouse, I don't know, here's the paddle, and here's my mouse. Like if my mouse goes over here, this is my best drawing of a mouse. If my mouse goes up here, the paddle better follow. That's the hope. Okay, and it needs to only follow in the X direction, because if my mouse is over here, the paddle still needs to go up, but not like over or anything. Okay, so that is the name of the game. So when the green flag gets clicked, let's forever follow the mouse. Okay, forever go to, set your Y to whatever the mouse's Y is. Dun dun dun. Set Y to, and let's find our mouse's Y position. Goodness knows where that is, but it's going to be somewhere. Mouse Y. There we go. Set Y to mouse Y. So when the green flag gets clicked, paddle, please forever follow the mouse and set your Y coordinate to the mouse's Y coordinate. So the X now cannot change, which is super nice. So I'm clicking the green flag and bam, is it working? Look at me. I'm moving my mouse. I can put my mouse over here, but it's still only going up and down. Put my mouse over here, still going up and down. So it's going to keep following me until I hit the red stop sign. And it can't really go past if I go past either. So that's super nice. I would think we would prefer it if the paddle would start in the middle whenever we start this game. So let's set the paddle right there and make sure that it starts out in the middle whenever we start the game. So no matter what, stop the game, bam, when I start it again, it will start in the middle if my mouse wasn't there already. So maybe that's not the best thing to show you, but that is what's happening. The ball also should start in the middle. So if the paddle starts there, there's no easy way for me to stop the game. Does escape stop the game? No, unfortunately. The ball should also start kind of close to the paddle. Like we'll start the paddle there, start the ball here. We want to start the ball also moving in a weird direction. So not like towards the paddle. It should be random, but it shouldn't be like this way. It should be like, okay, you can go this way, this way, this way, all the way there. So like, let's pick some nice angles here. Okay, so let's figure out our angle limits, and that will be how we start the ball. So definitely, when the green flag gets clicked, we should put the ball right here in the middle. That would be nice. So go to this current spot that you're at. And we'd like the ball to shoot off in a random direction, a weird direction as well. But it should be something like this. Maybe like, I don't know, that's 40, 90. To get there from 90, we had to go 50. So we go 50 this way to get 140. Yeah? I think that is math. So let's set the ball's direction to be between 40 and 140. Yeah. Oh, what happened there? Zoom out, please. Odd. So we'll set the direction to be between 40 degrees and 140 degrees. Yeah? That's what we want to start the ball off at. And so we'll do that by saying something like, when you begin your life, go to here, and then also set your direction. Okay, so that will be point and direction, a random number again, but between those nice values. 40 and 140. Okay, and then forever just keep moving. So the ball will start off in the middle, no matter where it ended up. Start off in the middle, and then let's have it bounce. Yeah, keep moving. Forever move and bounce, like we know how to do now. Forever move, and if you ever hit the wall, bounce. Yeah. So now we essentially have most of the game. The ball is bouncing forever and ever. It's moving 10 steps if on the edge bounce. And it's eventually going to get to the paddle, though, and we are not interacting with the paddle at the moment. So that's our next game to play. We should have the ball bounce off that paddle. Okay, so we gotta bounce it off in the opposite direction. Okay, sadly, there's not an if on edge of paddle bounce block, but we can make our own. We can do our own little thing here. So the hope is, dun dun dun, if we ever touch the paddle, we should also bounce off of that. So in addition to if we're on the edge bounce, if we hit the paddle, also bounce. Okay, so if, are we currently touching the paddle, then we should bounce. Okay, so let's try, we're trying to bounce two ways. So if we hit the edge bounce, and if we hit the paddle bounce, we'll never be hitting the edge and the paddle because of the way this works. Those can never be the same. So we'll just, okay, see if you hit the edge, and if so, bounce. And then also see if you hit the paddle, if so, bounce. Okay, hopefully that makes some sense. And so yeah, if you're touching the paddle, then you need to bounce. What does it mean to bounce now is a philosophical question. So the easiest way to do it is if the ball's coming in, bam, we can just have it flip a 180. That's not really what should happen. I'll talk maybe in a future lecture about how to make it nice, much nicer than that, but we can just make it flip 180. Okay, so change its direction by 180. Bam, go that way, 180 degrees. That's a bad 180. Yeah, that's the idea. So if we're touching the paddle, then please change your direction by 180. All right, so point in direction, whatever it was, plus 180. Yeah? Dun dun dun. Direction. This gets your current direction, of course. And then we're going to say plus 180. Plus 180, and that'll be the opposite direction. So it's saying point in whatever direction you were, plus 180. Okay? Point in the opposite direction. Okay, so hopefully it's all coming together for you. It's this is the balls program at the moment. It's gonna start off in the middle, all nice, and then pick a random direction that's in the right direction, going to the right somehow, and then forever keep on moving a little bit. Move if you can, and if you can't, bounce off if you're on the edge. Alternatively, if you just hit the paddle, oh man, you should bounce off of that. Okay, so you should also point in the opposite direction. So let me show you this working. Or maybe there's a bug and we'll fix it. So I'm going to put the paddle next to it. Bam, it bounces off. Isn't that nice? So it notices that it's touching the paddle, and it points in the direction that's opposite, whatever its current direction is, plus 180. And you can watch it change down here at the bottom if you'd like. Whee! So that's fun. That is a really exciting game, and it's always different each time because it bounces off in a new random direction. Doesn't like to bounce up now, does it? There it goes. So it's always a new game, and now we just need to be able to lose this game. Okay, so enough with the ball and the paddle. Let's also talk about the ball and the line. Okay, so here's how we want to lose the game. If the ball goes underneath us or above us, it's going to eventually hit the wall, and we can't check for touching the wall, but we have put the line right where the wall is. Okay, and this is why we can check for touching the line. Yeah, that's the hope. So let's put this in the lines program. We could just as easily put it down here as another if statement, as another if block in the balls program, but this makes it easier, I guess. When the green flag is clicked, forever line, this is the lines program now, remember, forever keep checking if someone has touched you. Keep checking if the ball touched you, okay? If I am touching the ball, if that's the case, then the game is over, okay? So we want to stop the game, okay? So there's a few ways to do it. You can be like, okay, say game over for 2 seconds or something. That works. Let me show you this working. So it could bounce off the paddle, or we could lose the game. So I'm going to have the ball touch the wall. And so it's going to be like, oh yes, the wall is saying game over, but the game's still continuing. That's no fun. We would like it to stop. We would like this game to stop. And so there's a nice stop block I talk about here to make the game stop completely. It stops all the animations. It's the stop block. Okay? So stop everybody's program. Okay? That's the idea. So stop everybody's program, and you can see it's all nice and cute. You can see how this is the last possible thing that could ever run, because you see how it can't hook in anything at the bottom of it. It doesn't look like a block anymore. It looks like the very last thing, just like this one has nothing, like the event blocks have nothing that could come before them. This one has nothing that could come after it, because it's going to stop everything. Okay? So now let me lose the game again. It'll be like, game over. And then 2 seconds later, it's going to stop everybody. Bam. So now nothing works. It stopped the entire program. And the issue is, well, this is all well and good. It's saying game over for 2 seconds. But that's no fun. I would like it to immediately stop the game. You can say game over for fewer seconds, or just say it. But it just won't work, okay? So there's a better way. One, we could just do it like this, and just be like, okay, just not say anything, bam, over. The alternative is extra cool. We can make our own little sprite, and you will be doing this in your programming assignments. That's why I'm teaching it to you now. Choose a sprite. No. I'm going to paint a sprite. I'll make it myself. So you can say game over. And you can make the font all huge. So you can say, I don't know, drag this box, I guess. Yeah, cool. And then you can put this in the middle if you would like. It looks like it's showing me the middle is there. And bam, it's there in the middle now. This can be called the game over sprite. And now, in our program, we're done. This is like the costumes tab. We can go back to the code tab. And we could say, okay, before you stop everybody, you should show that sprite. And how else can we show something other than using message passing? We're good at that now. Let's make a new message, call it game over. And so we'll have the game over sprite listening for the game over message, and when you see it, well, just show yourself to display game over. Whee! And you should, of course, start out hidden. So at the very beginning of the program, when the green flag is clicked, please start out hidden. Okay, so this is the program that runs for the game over sprite that we just made. It starts out hidden, and then whenever it receives the game over message, it shows itself. And that is the idea. Whenever we lose the game, whenever the ball touches the line, that's when this happens. Okay? And now it is time. Let me show you this entire game running. Let's go over everything just to understand how it's all working. It's all not too bad. The most complicated program is in the ball because it's doing a lot. So the paddle, here's its program. When the program starts with a green flag, it's going to go to its initial spot, but then it's immediately going to go to the mouse pointer, so it's probably going to go straight up. And it's going to keep following the mouse pointer forever. Yeah? The ball is going to go start in the middle as well, close to the initial spot of the paddle, and then pick a random direction to go off into towards the right. And then forever it's going to move in that direction, if it can. It might be on the edge, if so it's going to bounce. And it might touch the paddle, if so it's going to bounce off of that, and not go farther forward into the line and stop the game. So that's the ball's program. The line, when the game starts, when the green flag is clicked, it's going to keep on checking if something touched it, specifically if the ball touched it. If the ball did touch the line, which is supposed to be the edge of the board that you're never supposed to get to, that means the game is over, and we're going to broadcast the game over message. Okay, and that's going to stop the entire program with this stop all block. That can't have anything after it. Okay, so that's what happens when game over begins. It's going to say game over. It's going to shout out game over. And now our game over sprite is listening for that. It's going to start out hidden, and then when it receives the game over message, it's going to show itself and say, okay, yes, announce to the world, game is over, you lost, you suck. Okay, that is it. Are you ready? It's all working together. There it goes. Bam. So I'm playing the game, and I can look at the line while it's playing probably. Let me lose the game now. Okay? Hey! So, the ball touched the line, it noticed, and it broadcast the game over message to show this game over sprite right before it stopped the entire program. Okay? That's the idea. That's the beauty of it all. So, that is the game in a nutshell. And there's a bit of a bug, I was just researching it, that causes you to need to tap the green flag twice to restart the game. And the issue is because this line, when you click the green flag, it can't move the ball fast enough so that it gets away from the line. So it's still technically touching it. So it immediately stops the game and then also moves the ball over here. And then you can click the green flag again. So one way to get around this, if you really cared, was to, because you know it's not going to hit the ball, the line's not going to hit the ball for a while, because it's going to start out at the beginning of the game, moving to the right. So you can just wait a small amount of time, wait 1 second before you check for game over. And that will prevent this little bug, but it's not a big deal. So don't worry about it if that didn't make sense, but now it makes it so that you can click the green flag just once and have the program restart itself. Okay, so I encourage you to play around with this game. It's really fun. Study it. Hopefully you enjoyed all this, and it's all making sense to you. That's really important. Please come yell at me in office hours if it's not. But that is Pong, and I'm going to save it before I forget. Okay, so that is everything. Now let's talk about your programming assignment, and then I'm going to give you plenty of time to do it. So here it is. What you're going to do is you're going to make Space Invaders. So another old game. So this man is going to teach it to you. So you're going to make this game Space Invaders in Scratch. So you're going to follow his directions, and he's going to walk you through exactly what to do, and that is essentially your programming assignment. It's going to be different from normal Space Invaders in that you're going to shoot tacos instead of like aliens, but that's half the fun, right? So yeah, this is what you're going to do. Just follow these instructions, and then you can submit. You can change whatever you'd like. You can change your version of the game as much as you want. Just make sure to have all of the features that are talked about in this video. Okay? So that's all you need to do. And to submit, please upload a video. Show me your program running. Show me your code visible. I just want to make sure that you understand it. You can record it however. Please yell at me if you're having trouble. And yeah, just walk me through how your program's working as you demonstrate it. It doesn't have to be very long. Just like under a minute is fine. But yeah, hopefully this is enjoyable to you. You make a little cute game that keeps track of your score, and you shoot tacos or whatever other sprite you would like. And yeah, it's just building on top of everything we've talked about today, and I hope it's fun. So that is Space Invaders, and that is your next programming assignment. So that's all I have for you. With that, I guess I will see you next week. So I'll see you then.